Okay, so let's solve some 11.3 equations, right? Now we're solving equations, not just evaluating. So the first step on these is usually, or maybe the easiest kind, is the ones where you just have to evaluate part of it, right? So what's log base 6 of 36? Okay, so this, right, is the same thing as x equals log base 6 of 36 is 6 squared. So
it's going to equal 2.
So this left-hand side is 2, right, and that's x. You guys see that?
Oh.
So this wasn't really much of a solve, right? Because all I really had to do was evaluate the left-hand side. This is as easy as solve gets, right?
Yeah. So it's going to be x equals 2.
Okay. So let's talk about this one. This is asking, what base do I raise to the second to get 4? So this is saying x squared is 4, right?
Yeah.
So x has to be 2. So this one actually involved I had to undo something, right? You guys see what we missed? What did we undo? Yeah, here we took a square root, right? When we take square roots, what are we responsible for introducing? Plus or minus. So I need a plus minus square root, right? Which gives me not 2, but plus minus 2. You guys see that? So the log base 2 of 4 is 2. The log base negative 2 of 4 is also 2. Right? Because I square them both, I get 4. You guys see that?
That is literally the one rule I hate the most.
Yeah, this is maybe the hardest thing to remember in beginning algebra is this. Okay, when I take a square root, it gets a plus or minus. When I'm just evaluating a square root, it doesn't, right?
Okay, so when you solve it is, when you evaluate it.
Yeah, when I solve, when I put that thing in there, I need to account for both halves, right? That's me asking, right, this thing, if I thought about this graphically, is there's a parabola, not that one. There's a parabola, this one, right? Goes through 0, 0. And I'm asking, when does it hit 4? In other words, where are these two intersections? There's 1 over 2, and there's 1 over minus 2. You guys see that? So I have to count for all the intersections on the graph. That's me, right? So when I put this root in there, I have to account for those. You guys cool with that?
This one is all the
Okay, so how about this guy?
That's the third.
Okay, so I'm looking for, this statement says x to the what is what? Third is 8. So x cubed is 8. Now what do I do to both sides? Cube root both sides. So I get x is 2. Why don't you need a plus or minus? Because odd roots are actually inverse functions, right? Cool. Very nice, guys. How about this one? What's this one?
That's a whole problem.
This one's a whole problem. This one's actually pretty easy. Why is this one pretty easy? Oh yeah, because I know what log base 3 of 3 is. What is it? 1. So that was just an evaluate step, right? And now I need to add 1 to both sides, right? So I get 2 is 4x. Then I divide by 4. So I'll get 1/2 is x.
Could you write it the other way just because it makes you feel better?
Sure. Yeah, swap the order if it makes you feel better. Right? X is 1/2 is also fine. Last time we did inverse functions, right? You guys remember that? So when we did inverse functions, if I was finding the inverse of 4x minus 1, do you guys recognize that that's add 1, divide by 4? That is the inverse function. Every time I've been solving an equation, I've been manually constructing the inverse function down this side. You guys see that? Yeah, you've actually been making inverse functions the whole time. You guys see that? This one actually is an inverse function. This one actually is, this one right here, actually is an inverse function. This guy isn't. Because I tried to invert the squaring function, and the squaring function doesn't have an inverse. See, I got 2 answers. That was 1 input for 2 outputs. That thing's not a function. Yeah, it fails the oh. I was doing the horizontal line test, right? I knew it failed. It doesn't mean I can't solve the equation, but it means that I can't make an inverse function. You guys see that? I can make an inverse process or something, but it's not a function.
So, for the first one, negative was lower than that.
So could x be negative here? No. Yeah, because 6 to the minus 2 is 1 over 36. You guys see that? Cool. You want to try the hard one?
Yeah.
Okay. Right? Yeah. Now this is going to be the hard thing, because this is the skitter deal. So we've got a log in there, we want to get it out of there, right? Okay, so how do I normally get something that's annoying to me out of there? Yeah, I'd kind of do the opposite of it, right? So there is an opposite for logarithms. It's raise it to the base. You guys see that? So I'm going to apply to this side, to this guy, to both sides. And I've been doing this and I just didn't tell you. I'm going to apply 2 to the whatever to this thing. So I'm going to feed both sides of this into the 2 to the whatever function. So I'm going to get 2 to the log 2 of 3x minus 4 is 2 to the third. So this is literally just me putting both sides as exponents on a 2. Cool that? Now why would I do this? Okay, so earlier we were canceling 2's and log 2's the other way, right? Like when I had this, I would cancel the log 6 and the 6, right? They cancel the other way too, because they're inverse functions. So this 2 and this log base 2 cancel, and all this junk falls down. So I get 3x minus 4 is 2 cubed. Why not 3? Where? Here? No, I started with a 3 over there, and then I raised both sides to the 2. So I put a 2 down here, and then put both these sides on the exponent. Yeah, and now I can just solve for x. Because I know what 2 cubed is.
It's 8.
2 cubed is 8. So I'm looking at 3x minus 4 is 8. So what do I do to both sides? Add 4. I got 3x is 12. Then I divide by 3 and get x is 4. You guys want to see a really cool connection?
Okay, what do we call that when we bring the 2 down?
This thing?
Yeah, what should we?
I would call that exponentiation. But some people would call that a skitter. Right? That's the 2 skitter. It gets rid of log base 2s.
Okay.
You guys see that? Drags them out of there.
So we can use that to any, whatever log that is, we can use that out there to get rid of it?
So it won't work if you have, so if you have a log base 3, raising everything to the 2 won't help you out, but raising everything above a 3 would.
Okay, so we're just matching. whatever.
Yeah, we're matching the base.
Okay.
Cool? So, you guys want to see the cool thing? If we had a function of x, right, that's this thing. That's log base 2 of 3x minus 4. Okay? Right? If I think about function blobs, what's the first thing I do to an x when I stick it in there? Yeah, multiply by 3, right? Then that gets me to this, so I started with an x, that gets me to 3x. Then I should subtract 4, that gets me to 3x minus 4. Then this function's hard to write down. What is it? What's the next thing I do?
You minus 4.
I already subtracted the 4, so I'm now at, I know what this number is now.
So you're gonna divide rid of the log?
No, then I evaluate the log on it, right? So I ask, what's the log base 2 of whatever number I had? So that's applying the log base 2 function. So I get over here, and now I'm done with my function evaluation. I've got log base 2 of 3x minus 4. If I want to go backwards, what's unlogging?
Raising it.
You want to define it.
Raising it to the 2. What's unsubtracting 4? Add 4. What's unmultiply by 3? Divide by 3. You guys see that's what we did down this side? So if I want to write down the inverse function, right? F inverse of x. Cool. I start with an x. Then I put a 2 under it. Then I add 4. Then I divide the whole thing by 3. Okay, see that? I just found the inverse function for that. You guys cool with that? So, my point here with this is that these inverse functions that we were doing the other day, right? They're not really magic. They're the same thing I've been doing to solve this whole time. I've been manually making an inverse function. Because what I'm trying to do is I'm trying to say, okay, here's a function of x, right? So in this case, it's a logarithm that's shifted around a bit, so it looks something like this. And then here's a level, right? And I'm looking for this intersection. You see that? So this is a picture, roughly, of log base 2 of 3x minus 4. And this is 3. Right? Y equals 3, maybe?
The little circles, the log base.
No, this arc is the log base 2. Because it's what happens when I take an exponential, right? Exponentials look like this. When I do the inverse function trick to them, I flip them over, y equals x. They look like that.
So we're doing the glass thing.
Yeah, so I started with a, this is 2 to the x, maybe. And then I flip it over. If I was being really honest, I would say that's the graph of this one. Right? And then I flip it over, I end up with an arc like this. And I'm wondering, where's this intersection? That's what solving does. You guys see that? So the x value is this guy, wherever the heck the x-axis is. Cool?
So it relates to
Everything. Cool?
If you do another one like that, that would be.
Yeah, let's find another one.